All right, let's try a problem here where we have to do a little bit of everything. So we have in this problem a solid cylinder, radius 20 centimeters, mass 10 kilograms. There are two constant forces acting on it. The cylinder is released from rest. What will be its angular speed after 3 seconds? Okay, so the first thing to realize here, we want to apply the tau equals I alpha based framework. So step one, we need a free body diagram. That's been given to us in the question. So step one is already done. Step two, make sure you note the axis of rotation. So this one's going to be rotating about its center, presumably. It doesn't really explicitly say that in the question, I guess, but I presume that this cylinder is going to be rotating about its center point. So there's my axis of rotation. Next up, we need to convert the forces into torques. So I'm going to go through this a little bit quicker than I have in the previous videos, or else this problem is going to be epically long. We have two torques to calculate. Let's call them 1, and we'll call this guy 2. So for torque 1, this torque is going to be counterclockwise, so that's positive. Ft is going to be 15 sine of 30, 15 newtons, sine of 30 degrees, and L is 10 centimeters for that guy, which is 0.1 meters. Okay, so torque number 1 is 15 times sine of 30 times 0.1 is positive 0.75 Newton meter. Torque 2. This torque is acting in the clockwise direction, which means it's negative. Ft is going to be 25 sine of 10. And the distance to the axis is 0.2 meters. So we're going to have 25 times sine of 10 times 0.2 gives me negative 0.87 Newton meter. Okay, maybe we better keep an extra significant figure because it looks like we might get some cancellation pretty soon. So let's call it 868, and this one was 750. So now when we take the total torque, it's going to be positive 0.750 minus 0.868, and that's going to give me 750 minus 868 is negative 0.118 Newton meter. Okay, so I calculated the torques and I summed the torques. The tau side of tau equals I alpha is done. Now we can move over to the I alpha side. I in this case will be easy because there's no parallel axis theorem. The cylinder is rotating about its center, so all I have to do is look it up in the table. The center of mass, moment of inertia for a solid cylinder, I remember is 1/2 mr squared. So that's 1/2 times the mass of the cylinder is 10. R here is the radius of the cylinder. It has nothing to do with where the forces are being applied. So the radius of the cylinder is 0.2 meters square. So we get 0.5 times 10 times 0.2 square, and we get 0.2 kilogram meter square as the moment of inertia. And so then we can plug all this information into tau equals I alpha. So tau is negative 0.118. I is 0.2 times alpha. So that means alpha is negative 0.118 divide 0.2, and that's 0.59 units of radians per square second. The fact that alpha is negative means that if you release this cylinder from rest, it's going to move in the clockwise direction because negative means clockwise. Now, alpha is not actually what we were asked for. What we're actually asked for is what will be the angular speed. So that's omega that they're looking for after 3 seconds have passed. And you might see what we're really being asked here is to set up a kinematic style problem, because we have constant forces, so that'll give us constant torques. So kinematic equations apply. We're being asked to calculate omega final. We've got a time elapsed of 3 seconds. It's released from rest. So that gives me an initial omega of 0. And I can also use my alpha as a known piece of information for the kinematic equation. So that gives me 4. So my kinematic equation is going to be omega F equals omega O plus alpha T, which is the analogy for VF equals VO plus AT. So I've got, this is 0 minus 0.59 times 3. So it turns out all I have to do is multiply alpha by 3. And I get a final omega of negative 1.77 radians per second. So that's the final angular velocity. Technically, they asked for the final angular speed. So really what they want is the absolute value of the angular velocity. So that would be positive 1.77 radians per second, because speed is always positive. So here's a problem where we had to calculate torques, we had to calculate moment of inertia, we had to do rotational kinematic equation problem, we had to apply tau equals I alpha, and all of the skills we've been building up over the last period of time. So this is kind of like the final culmination of this rotational motion section. But if you can understand a problem like this, you can understand most everything that we've seen so far.